All right, so you have um, learned how to look at this form down here and describe its transformations. We know that this right here is a vertical shift. No, I'm sorry. We know it's a vertical stretch. We know that because that's the value of A, it's bigger than 1, so we know it's going to stretch it vertically. We also know that it's going to take each one of the Y values and it's going to triple it. We know this is H, and we know it's going to shift it left and right, and we know this is K, which is going to shift it up and down. So we know about this, but what we don't know, well, you kind of do. What we don't know is how to take it from this standard form right here and turn it into this. You do know how to do it. It's because we're going to use the completing the square process, but there's a few things different. So the first thing that we would do if we were solving this by completing the square is we would divide everything by 3 because we can't have that leading coefficient. Okay? And then this would turn into x squared minus 4x plus 7/3. So we know that's what we would do if we were solving this. And of course, it would be set equal to 0. Well, this is the first thing that we're going to do different. We still have to get rid of that 3. That 3 is still in the way. But instead of dividing everything by 3, we're simply going to factor the 3 out of just these first two terms. We're not going to deal with the 7 because we're going to get it out of the way. But we're going to factor 3 out of those first two terms because making it go away is going to make us not know about that vertical stretch. So we have to leave the 3 in the place. So we don't divide it out, we just factor it out. So understand that when I say I factor it out, I understand that 3 times 1 gives me 3, and then 3 times 4 gives me 12. So since they both have that factor of 3, the 3 is going to be written on the outside. It's kind of like I'm undistributing the 3 from these two things. It's on the outside. And then if I undistribute the 3, this would be what I have left. So you factor the 3 out. Then the next thing you do over here, we would have made room for our wish. We would have subtracted 7/3 from both sides to leave room for the number that we're going to wish for. We'd make room for our wish. Remember, we did that. We're going to do the same thing, except we don't want to move it over here on this side of the equal sign because we like f of x to be all by itself. So we're still going to make room for it. We're just going to scoot the 7 out of the way. And I'm going to make room for it inside that parentheses. All right. So I'm not adding and subtracting anything from both sides of the equal sign. I'm simply going to squish the 7 out of the way and give myself room for this new one. Okay, so now that I've made room for it, I'm now going to I'm going to make the wish. And remember how we make the wish? We do half of B. B is -4. We'll take half of it and then we square it. Well, -4 divided by 2 is 2, and then 2 squared gives me 4. So I'm going to put a 4 right there. Okay, so I put a 4 in the place right here, but understand that that's changing my equation. I'm adding a 4 inside the parentheses, and then that 4 that's inside the parentheses is being multiplied by a 3. So I've changed this side of the equation by making it plus 12 bigger. Okay, so when I put the 4 right there, that 4 is going to be multiplied by that 3. That means that I've made this side of the equation plus 12 bigger. Well, it's not going to be equal unless I have one of two things. I can add 12 to this side of the equal sign, which I can completely do. But again, remember, I'm trying to keep this f of x all by itself. So the other thing that I could do, instead of adding 12, is to just come over here and take 12 away. So I can add 12 to this part of the equation and then take it away over here, and I've not changed this side of the equal sign. So that's what they're doing right here. They're taking that 12 away. So they added 12 to this part. They're going to turn right around and subtract 12. Why did they write it as a -3 times 4? I guess just to explain to you that it's whatever this and this number is. If you've added it right here, you got to turn around and take it away. And we're doing all that to maintain equality. So, why do we want a wish? Why do we make a wish to begin with? So we can write it in its squared form. So this becomes this part right here. It's in its factored form. And then we just simply combine like terms. Why? Because we can. And then that gets us to our perfect square. So rewatch the video or go through this again. I'm going to stop it, and my next video will be us working another one.